Okay. Saya, I don't know, benda ini terjadi lagi. I was, I have to, the computer restart by itself. So I'm sorry about that. So now we go back to the discussion. Where were we? Okay, kat mana kita tadi? Wait, I got to find balik the notes. All right, so the Lagrangian multiplier, all right, it's optimization problem. You will want to minimize or maximize an objective function. Objective function f of x, y, subject to a constraint. And that constraint is also a function. So let me rewrite myself. I don't think it's no, it's not. So so you have the. So I will continue from where we left. Okay, I have the optimization problem. So optimization problem. Okay, you want to maximize an objective function. If function, all right, f of xy, f of xy, subject to a constraint. G of xy equal k, right? Where k is a constant. So here you have only two functions, but there are more than two independent variables. You have the objective, which is a function, and then the constraint is also a function. So it's like, it's like a constraint maximization problem. Application mostly in economics. If you recall, in economics, you have limited resources. Okay, you have unlimited needs, you have unlimited wants, but you have limited resources. So the unlimited ones is the objective. The constraint is the limited resources. So if you look at economics, if you look at the consumer problem, now consumer, what do we maximize as consumers? What is the objective of the consumers?
Maximize satisfaction.
You want to maximize your utility, okay? Utility or satisfaction. But you cannot maximize your satisfaction indefinitely, all right? Because we have limited what? Limited resources. So you have limited income. So subject to ST means subject to income constraint. Okay, the income is our constraint. So it be something like that. Okay, so that is our problem. And then this is also true if I want to minimize. It's not only to maximize, but you can also do a minimization problem. I want to minimize an objective subject to certain constraint. So that is the problem. Now, the method, the method to solve this is by using the Lagrangian multiplier method. Okay, Lagrangian multiplier method. So the method, the Lagrangian multiplier is the method. So the method to solve that problem is by the Lagrangian multiplier method. Okay, all right. So there is a difference, all right? The problem is the optimization problem. The Lagrangian is the method. So that's a method how to solve the problem. Now, when you want to solve the problem, given the problem here, you want to find what? You want to find the optimum point. You want to find the optimum point. To find the optimum combination. Okay, combination of X and Y. Call it X star. The optimum. Okay, X star, Y star. That what? That solve our problem. Okay, you want to find the optimum combination of X and Y. We call it X star, Y star. That solve our problem. Okay, that maximize, or you can I can bring it. I bring back my arrow up. That maximize or minimize the objective given the constraint. Okay. Okay. So you want to find the optimum point. Optimum point is the point that will solve the problem. You have maximized the objective, which is subject to the constraint. Okay. All right. So now what we do, okay, the method is the following. We define a Lagrangian function. Call it a Lagrangian function. By introducing another variable, lambda. Okay, so lambda is a variable. So now you have a function L that made up of three variables, X, Y, and lambda, because you have introduced now another variable. Okay, a variable. A variable ni sekali nampak terlampau rapat dengan B itu. Should be here. Okay, a variable. So the Lagrangian, you call it L, which is now a function of X, Y, and lambda. That will be equal to the following. Will be equal to the objective, f of xy, plus lambda that we introduce, multiplied by the constraint, d of xy minus k. So what we do here is, we put together, okay? You put together the objective and the constraint into one function, and multiply the constraint by the multiplier, the lambda. Then you have the Lagrangian function. So Lagrangian function, in short, will be what? Will be determined, or will be made up, or be influenced by three variables, x, y, lambda. So now you have three variables. Okay, all right. The only thing is that you need to rewrite. Okay, if I can go back here, you need to rewrite the objective. Oh, no, I'm sorry, the constraint. The constraint given as g of xy equal to k. All right. So what you need, you just rewrite that thing in terms of what is here. All right. So you have to rewrite lah. Benarnya, you have to rewrite the constraint g of xy equal to k. As you bring the constant to the left, you got g of xy minus k equals 0. So you have the thing, that is the form. All right. Okay. Any question? So the method is quite smart. You have the two functions, the objective and the constraint. You bring it together, introduce one variable, you have one function, and then we can solve for the x and y, the optimum point. Okay, so that is the method. Now, how does the method work? All right, this is how. What you need to do here first, you get the first partial derivatives. You get the first partial. We call it FOC. Okay, FOC, we call, that means FOC ni maknanya first order conditions. It's just like critical point. Okay, first order condition. That means the condition on the first derivative. Okay, the conditions on the first order derivative. First order derivative, first partial derivative. Okay, we call it FOC. So In short, we just call it f of c. Now, you take the derivative, partial derivative of the L, the Lagrangian function, with respect to the variables. How many variables do we have? We have 3. So we do for all 3. So number 1, I take derivative of the L with respect to x. And then I take the derivative of the L with respect to y. Finally, I take the derivative of L with respect to lambda. So that is what we're going to do. Now, if I take the derivative of the L with respect to x, what do I get? What are the variables that has x as the independent variable? I got what? I got f of xy. Okay? And then I got the constraint here. Okay? So what is it? It is fx. Okay? It is fx plus I have g of xy here. You know, g which is depending on x. But the g is multiplied to lambda. So you've got the lambda multiplied by g. Okay? Now, what is the condition for critical point? The partial derivative is 0. So set that to 0, call it number 1. Okay? All right. Now, take the derivative of the L with respect to y. What do we get? What do we get? We get fy plus lambda. And then you got g, which is a function of y. G, y. And that g is multiplied to lambda. So set that to 0. It's number 2. Okay? Now, number 3. You take the derivative with respect to lambda. Okay, what do we get? Okay, this one is quite different. So I'm asking you, take the derivative with respect to lambda. What do you have? What is it equal to?
Lambda gx dy.
Lambda gx gy. Okay, lambda gx gy. Okay, that is yeah, but that is not really correct. Okay, anybody else? You are taking the with respect to lambda, no? The variable is the lambda. Okay, anybody?
GXY minus K.
Huh?
Oh, but
GXY minus K.
G of xy minus k, because lambda is the variable. Okay, g xy minus k is the one that is multiplied to the lambda. So think of it as the coefficient to the lambda. So if you multiply the lambda, I mean, you take the derivative of lambda, think of it like this. Say, okay, suppose L2 is equal to lambda, just lambda, okay? Just lambda only. And then here is the one that you have in the bracket, all right? G of xy. Apa? Senang sikit, I'm using another value. We'll show the easy first. Okay, let's say I have here, I just want to simplify this because I want to show the partial derivative with respect to lambda only, right? So let's say lambda multiplied by 2. Okay, now I want to take derivative of the L with respect to lambda. So I have only one lambda, okay? So what is the derivative here? What is it equal to?
2, sir.
2 lah. Okay, because I take derivative of the lambda, that is equal to 1, and you have the coefficient which is 2. So similarly for here, okay, you have got lambda multiplied by everything in the bracket, which is just think of it as number 2 or number 3. So what? So that will be equal to just the things in the bracket. So you got g of xy minus k, okay, equal 0. And another way of doing the derivative with respect to lambda, so that we are not confused, you know, at the beginning, is that we multiply that out. So you multiply the lambda right away. So you got g of xy multiplied to the lambda minus lambda multiplied to the k. So this one, you won't miss it, all right? So you have here two terms, lambda, g of xy, lambda k. Differentiate with respect to lambda, what do we get? We get g of xy, the first term, minus k. Okay, so one way is to multiply out with the lambda with all the terms in the bracket. So that is our number 3. So now I have 3 equations, 3 variables, x, y, lambda, 3 equations. So we can solve for the x and y. So now what you want to do based on this, you want to find the optimum point, call it x, y, x star, y star. And of course, you can find the lambda star, but we don't need the lambda. We only need x, y. So we don't worry about the lambda. We only worry about the x, y. Okay. All right. Now, how do you solve it? Okay. The way to solve this is, first of all, you make use of 1 and 2. You write everything here in lambda in terms of the other terms. And then we will make use of number 3 to find the optimum x and y. So let's do that. So the method, okay, the method is we make use of number 1 and number 2. So from number 1, what is lambda equal to? You write things in lambda. Okay, oh no, you write lambda in terms of the other one. Okay, so I want you to look at number 1. You bring the fx and gx to the left, to the right, I'm sorry, to the right. What is lambda equal to? Okay, buat sekarang. Okay, what do you get? What is lambda equal to?
Negative fx per gx.
You have, so that means you have to look at this part now. All right, so the lambda is equal to negative fx divided by g of x. Now, you look at number 2. From the equation 2, you can also write lambda in terms of the other terms. So go back to the number 2. What do you get? Lambda is equal to what?
Negative fy
Negative
over
fy
g of y.
over gy. So negative of fy divided by g of y. So now, what can you do? You got lambda equal to something. Lambda is equal to something. Therefore, what?
1 equal to 2, sir.
1 equal to 2. So therefore, you got negative f of x over g of x equal to negative of fy over gy. Okay, negative and negative becomes positive. So you don't have to write the negative. It's just what? Fx over gx equal to fy over gy. Okay, now from this ratio or this relationship, I can do this. I can write x in terms of y, or you can write y in terms of x. It doesn't matter. Okay, it doesn't matter. You can do either way, depending on the relationship. So what you do next? You substitute. Okay, you substitute x equal to f of y, if you do that, or if you do y in terms of x, you substitute y into where? Which equation now? Into 1, 2, or 3?
3.
Into 3 lah. You cannot substitute into 1. Okay, if you substitute into 1, you are going backward. Because 1 and 2, you already take care of the lambda. Okay, so substitute into 3, then you will get x star, y star. Okay, so this is the general method. Okay, but you have to work out the detail in order to get this. So this is the method, all right? First of all, you make use of the 1 and 2. You will get lambda equal to some terms in x and y. And then from number 2, you do the same thing. And then you equate the 2, okay, because they are equal. So you can write x in terms of y or y in terms of x. And then you put into number 3. I can solve for the optimum point. Okay, all right. So let's quickly consider an example. So I will look at a simple example. Mana dia example tadi? Okay, tunggu dulu. If I cannot finish this example, you will do example here at home. Okay, example number 1. Let's say I want to maximize. Okay, I will do this quickly. Sebab ada kelas lepas ni. F of xy equal to 25 minus x squared minus y squared subject to. Okay, now ST means subject to the constraint. All right, the constraint. Let's say 2x plus 3y equal to 70. Okay, so now you write the Lagrangian. Okay, you write the Lagrangian, but you need to write the constraint in terms of what the Lagrangian form is. So Lagrangian, as we know, is the objective f of xy plus the lambda. All right, lambda multiplied by g of xy minus k. So you have to rewrite this thing. So that becomes what? Becomes 2x plus 3y minus 70 equal 0. So you can write it. And that is equal to 25 minus x squared minus y squared plus lambda multiplied by 2x plus 3y. Okay, 3x plus 3y minus 70. So that is our Lagrangian function. Okay. Now, we take the first partial derivative, we call it FOC, first order derivative, first LX. Okay, now what is LX equal to? LX equal to apa?
Negative 2x.
So you have that is the objective. You can put a bracket, okay? So that is equal to fx, okay? Fx is what? Negative 2x. And then you have here, okay, the lambda multiplied by 2x, 3y, 70. So, like I said earlier, in order for us to not be confused and make mistake, you multiply the lambda into the terms. So here I have lambda 2x plus lambda 3y, lambda 70. If you do that, then we will not make mistake. So take the derivative of the constraint, okay, multiplied by the lambda with respect to x. You have only 2x here. So what is it? What is it equal to? Plus
Lambda 2.
Lambda 2 or 2 lambda. Okay, set that to 0. So that is our number 1. Second, Ly. Ly is equal to what? It's equal to negative 2y. Okay, because here you have a y squared. And here you got a 3y or you got a y. So plus what? Plus lambda 3. Okay, equal to 0. Or you can write 3 lambda. Okay, so call it number 2. Now lambda, L lambda. Okay, if you take derivative of the L with respect to lambda, what do we get?
2x plus 3y minus 70.
If you look at the method just now, you will get the constraint. Okay, because the constraint is multiplied by to the lambda. But you can also do this. You multiply everything by lambda, so you got 2x. You got 3y here. I got 70 there. So you got the same thing. So I got 2x plus 3y minus 70 equal 0. That is 3. Okay. So from number 1, all right, from number 1, what do you have? Okay. So from number 1, what do I have? Okay, I want you to try. What do? Right. Okay, put me the, you write from number 1, you write lambda in terms of the x and y. Okay, I have 1 more minute. Okay, so from number 1, okay, you can write here from number 1. What do I get? I get lambda equal to what? Lambda equal to, so I think we do step by step. You know, you don't have to worry about anything. You will have lambda 2 equal to 2x. You bring the negative sign to the side, becomes positive. So lambda is equal to 2 over 2x equal to x. Okay, so that's number 1. Number 2, I got what? I got lambda 3, or you can use 3 lambda equal to negative 2y.
Positive, sir.
Positive 2y. The negative you bring to the other side, there is no more negative. So positive 2y. Okay, so lambda is equal to 2 over 3y. So you have lambda and lambda from 1 and 2. So what? So therefore, x equal to 2 over 3y. So now you have x in terms of y. Or you can also write y equal to 3 over 2x. So it doesn't matter. You can have x in terms of y or y in terms of x. That is your choice. Okay. So lastly, you substitute. Suppose I use x lah. So you substitute x equal to 2 over 3y into where? Into number 3. Then you will have the x, you will have the y. Okay, all right. So I will stop here because our time is up. I want you to finish it up. Okay, finish it up. Next class, we will continue from here. Okay, so that is the method. All right, that's the method. We call it the Lagrangian multiplier method. I think the method is quite smart. You know, it's compact. This method is actually very common in economics lah, because in economics you have this constraint maximization and minimization. Okay, any question, anything? All right, so make sure you know the deadline for the homework. All right, please submit. If submit after the deadline, will not be accepted. So I will stop here. We will continue next week. Any question, anything? No. Okay, good. So have a nice weekend. Okay, do the homework question. Yeah.
Next week, Monday, isn't it Agong's birthday?
If it is the Yang Tuan Agong birthday, we have to have a holiday. Okay, because Yang Tuan Agong is Sultan saya. So I have to take holiday lah. Birthday Agong hari Isnin. Ya, saya pun tak pernah tengok. Oh, Agong-Agong birthday ke Sultan-Sultan birthday. Kadang-kadang Sultan Selangor birthday pun saya tak tahu. Is it Agong birthday? Mana ni? Tak apalah. If you know Monday is holiday, then we don't have a class. Alright, so holiday tak ada, because we don't have to make up any class. Betul ke Monday holiday? Betul? Alright, so if Monday is holiday, then we'll not have a class. If Monday is not a holiday, then we have a class. Okay. Okay. Alright, anything else? Habis? Okay, I will see you again. Have a nice, so Monday holiday, so adalah sambung sehari. Ada sambung sehari lagi, so maknanya kita ada 3 lagi kelas lah. Next week we have 2 more weeks or last week? Next week? Is it the last week of a semester or is it the second last week?
Last week.
Last week, sir.
Last week Saya ingat lagi 2. Saya ingat lagi 2 minggu tau. Kartun betul lah. So kalau last week, maknanya I have only 1 more class lah. So it's okay lah. Macam mana? Alright, so next week, Wednesday tu, we will discuss about the midterm. And then in that case, the matrices ni kita tak payah cover lah. Okay, so bagus juga. You don't have, you have one chapter less to cover. That's good. You don't have so much, for the final. Oh, saya ingatkan lagi ada 2 minggu. I silap tengok kalender. Yeah. So next week, final week. Okay lah. So I will see you again, insyaAllah next week. Alright. So study tau. Study. Now you have to study. Don't think about holiday. Study. Okay, get ready for the final. Okay, get ready for the final. Because the final is, remember, 50% tau. 50%. So there is still, for those people who think they are quite bad, in bad shape, the final is still time for you to improve. So study now, okay? Study now. I will give you some sample question final. So don't worry about the final. Okay, I'll give you some sample question from last semester. Then at least you have some idea. But normally, okay, that's why I don't encourage people to do past semester, because past semester question will not be repeated this semester. Okay, there will be some different questions. Okay, sometimes the topic may not be included. Sometimes the questions are different, things like that. But what you can do is look at 2 semesters before. 2 semesters before, and this semester there might be some similarities. But not last semester. But for practice, that's good. Okay, practice memang bagus. Just for your practice. Okay, final 21st. Okay, final pun saya, actually I do not have a look yet at the schedule, So if the final is on the 21st, that means Monday. Today is what? Today is the 2nd. Our last class will be on the 9th. Betul, 9 lah. Kalau next week, last week. So kita ada lagi dalam 2 more weeks. From today it's about 3 weeks. So just nice, the time is just nice for you to prepare the final. The final is 21st. So we have ample time. Okay, all right. Any other things? Okay, so thank you for today. I will see you again next week. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you,
Waalaikumsalam.
sir.
Thank you,
Have a nice
sir.
weekend.
Have a nice day,
Waalaikumsalam.
sir.
Thank you, sir.
Thank you.
Thank you, sir.
All right, thanks.
Sir,
Yes.
sir ada kelas ke lepas ni?
Siapa? Saya?
Ke
Ada.
sir free?
Saya free. Kenapa?
Nak minta sir check midterm saya boleh, sebab ada setengah lecturer saya cakap midterm test saya hilang. Saya takut subjek ni pun hilang.
Apa? Takut apa?
Sekejap saya duduk depan kipas. Buat apa?
Takut apa?
Takut midterm test saya hilang sebab lecturer saya sebelum ni cakap midterm test saya untuk subjek lain hilang.
Betul. Not for you lah. Because there were cases, from last semester pun ada jadi. 1 or 2 students, they submit. But we never received. So I do not know what actually happened. Okay. But I think in our case, for our midterm, I don't know. So nanti I will check. So how do I check? Okay, which section are you in?
Section 11, sir.
Section 11.
Siti Najwa.
Okay, nanti saya tengok.
Okay.
Okay, tengok. Okay. So you know what? Now there is another class right now. So nanti saya WhatsApp lah. Do I have your phone number? Tak apa.
Nanti saya
Tak apa. I will put a message in the classroom. Okay?
Okay. Terima kasih.
Kalau tak ada, I put a message in the group.
Okey, terima kasih, sir.
Alright. Siapa nama? Siti Najwa.
Siti Najwa binti Mohta.
Okey, nanti saja.
Okey, terima kasih, sir. Assalamualaikum.
Waalaikumsalam.